Hello everyone, welcome to Joey's AP Precalculus lesson 1.3. Okay, so in lesson 1.3, we will be touching upon rates of change in linear and quadratic functions. We also talked about rates of change in lesson 1.2, but we're going to build upon that concept. We're going to learn about specifically the rates of change in linear and quadratic functions in lesson 1.3. Let's look at the lesson objectives directly derived from college work. Number one, determine the average rates of change for linear and quadratic sequences and functions. Number two, determine the change of rates of average rates of change for linear and quadratic functions. So we'll be also touching upon the change of average rates of change. I'll explain that in a moment. Okay, so let's look at our first key concept, which is average rate of change for linear functions, okay? Okay, so let's look at the definition. Please make sure to fill in the blanks while I am explaining these concepts, okay? Okay. So the first definition is the slope of a line is the ratio of the change in y coordinates to the corresponding change in the x coordinates. The slope of a line is the same as its rate of change. So think of the term slope as rate of change, the same thing, okay? So, explaining again, the concept of slope of a line is what? The ratio of the change in y coordinates to the change in x coordinate. So we touched upon the secant line and the average rate of change for nonlinear functions on the previous topic video, right? So for those videos, we treat it as if the secant line is the line connecting the two dots, and we found the average rate of change for that, right? So we're just bringing that concept again. If you want to find the rate of change here, just can pick any random 2 points and find the ratio of the change in y coordinates over change in x coordinates. For line or linear functions, because the ratio is consistent over the entire line, you can just pick any 2 random points, okay? This is same for what I've brought up like previous topic video. For nonlinear functions, we're gonna pick any 2 random points and draw a linear graph, so-called the secant line. And if we just find the slope of that secant line, we're finding the average rate of change between 2 points in a nonlinear function, okay? Let's solve some example problems. This is more likely driven from pre-algebra, so this should be easy. Find the slope of a line that passes through -4, 3 and 2, 5. Okay, so let's find change in y over change in x. So these are the y coordinates, right? So we're gonna subtract 5 and 3. And on the denominator, we have to find change in x. So we're gonna subtract 2 and -4. We find it's going to be 2 over 6. So we found out that the slope or the rate of change is 1 over 3. So the answer for this question would be 1/3, because the question just tells you to find the slope, nothing else. Find the average rate of change of the line shown below. I told you that the average rate of change of line is same concept with slope, right? So when we're finding the slope of the line, we just have to find any 2 random points. Why? Because the average rate of change of the line is consistent over the entire graph. So we're going to just pick 2 points. Let's pick this and this, okay? The coordinate for the top point is -2, 0. The coordinate for the bottom point is 0, -3. So we're going to do change in y over change in x again. So it will be -3, -0, 0, -2. So it's going to be -3 over 2. So the average rate of change of this line would be -3/2. This can be also proven by looking at the graphs. As x coordinate increases by 2, we can see that y coordinate decreases by 3. Okay, which kind of proves that this is the right answer. Let's solve some word problems, okay? This is more likely driven for the average rates of change for nonlinear functions because this is a quadratic function, right? The question tells us to find the average speed, which is same as average rate of change of the object from 1.25 to 1.75 seconds. So they give you the interval to find, right? So we're gonna plug in these two x values into the function to find the corresponding y value. H of 1.25 is negative 16 times 1.25 to the power of 2 plus 30 times 1.25 plus 4. Yeah, let's calculate this real quick. If I calculate this, I would get 16.5. Let's do the same thing for h of 1.75. It would be like this. So if you calculate this, you'll be getting 7.5, sorry. Let's do change in y over change in x, as if we're drawing a secant line that passes these two coordinates, okay? So we found the corresponding y value. So we just do 7.5 minus 16.5. And on the denominator, we do 1.75 minus 1.25. So if we do so, we will be getting negative 18. So the answer would be negative 18. But because the question is a word problem, you have to write the unit as well. It's speed, and they give you that it's feet and seconds, right? So it's going to be negative 18 feet per second. Okay. Yeah, so that's how you can find the average rate of change. One thing that I want to point out is for those of you who learn physics, yeah, I know that speed cannot be negative, but this is not a physics class. So if your answers turns out to be negative, just try to write the negative value, okay? Let's look at example 4. Find the average rate of change of the function shown below in the interval of 2, 8. So let's mark these points. This is where x is 2, and this is where x is 8. The coordinate is 2, negative 4, and 8, 2. We're finding the average rate of change, so we're drawing a secant line. Then we're finding the slope of that secant line, right? So we just have to do the same thing. So it would be 2 minus 4 over 8 minus 2. So it would be 6 over 4 or 3/2. So the answer would be 3/2. Okay, now let's look into lesson objective 2. This is the really hard part because it is hard, and this concept is also appearing in AP Calculus. So learning this correctly will help you a lot. So we're first going to look into the change of average rates of change for a linear function, okay? So think of it as because like we found the average rates of change, right? What is the change of that average rates of change? Okay, we're going to look into that. This is also called as the second derivative. You'll be knowing this when you go to AP Precalculus, but you can disregard for now, okay? Let's fill in the blank first, okay? Okay, let's read. Because the average rate of change of a linear function over any length input value interval is constant, the rate of change of the average rates of change of a linear function is 0. I'll explain this in a moment, okay? Let's look into this 3 graphs. This is more related to physics, but it's still related to math. So this is the position graph. This is the velocity graph. And then this is the acceleration graph. Velocity is the slope of position. Acceleration is the slope of the velocity. Okay. If the original position graph is a linear function, if you think of what is the slope of a linear function, let's bring up an example. What's the slope of y equals 4x? It is 4, right? So the slope function of the position function would be a constant. So if this is y equals 4x, this would be y equals 4. Okay? So this is the graph that represents the average rate of change of the original function, okay? But think of the slope of this function. The slope of a constant function is 0, as we have learned in lesson 1.2, right? So it's 0. So taking this into consideration, taking everything into consideration, you can say that the change of average rate of change for a linear function is 0. You understand? Because the average rate of change of a linear function is a constant like this, the average rate of change of a constant graph is 0 as proven in lesson 1.2. So therefore we can say that the change of average rates of change for a linear function is therefore 0. What about for a quadratic function? Because the average rate of change of a quadratic function over consecutive equal length input value intervals can be given by a linear function, the rate of change of the average rate of change of a quadratic function is a constant. I'll also explain this to you guys, okay? So this is the same. This is the position graph, velocity graph, and the acceleration graph. As I told you, velocity is the slope of position graph. Acceleration is the slope of velocity graph, okay? We have the quadratic function right here. Think of it as this, okay? We're just having the right half of it, okay? We're gonna find the average rate of change of each interval as how we found by using secant lines, okay? If we take these 2 points and draw a secant line, and if you draw these 2 lines and draw a secant line, and if you draw these 2 lines and draw a secant line, you can see that the secant line's average rate of change is increasing, right? Let me visualize it better. Yeah, if you take a look at this, you can see that the slope of this is kind of flat, right? But the slope of this is steep. You can note that as the quadratic function progresses, it will show a overall graph of a linear function. Explaining this better, sorry. Let's just point this point and this point. Okay? And then if you're finding the average rate of change of this interval, we're finding the accurate representation would be finding the secant lines, right? Then it will be a linear shape. And because we know that the slope of a linear function is a constant, we can ultimately take into consideration that the change of average rates of change for a quadratic function is a constant. I will explain this better by solving some equations. Okay, now let's look at concavity. Okay, so concavity means that if the rate of change is increasing, it's concave up. I taught this in lesson 1.1. Concave down means that the average rate of change is decreasing. In other words, when the slope is decreasing. When the graph is having a shape like this, we call that it's concave up. Why? I don't get it. It's decreasing, right? It's technically decreasing, isn't it? No. I'll explain you why. If a slope is like this, guys, it's negative, right? So if you take a look at these 2 points, and if you draw a secant line, the average rate of change is a negative value, right? But if you take a look at these 2 points, the average rate of change is almost 0. So for these kind of shape, as the graph progresses, it's changing from negative to 0. Negative to 0. It's increasing, right? So the slope is increasing. That's why we see that for these kind of graph shapes, it's concave up. What about the opposite situation? For these 2 points, if you take a look at draw a secant line, the slope of that secant line is 0, right? If you draw these 2 points, and if you draw a secant line, it's a positive slope, right? It's increasing from 0 to positive. So this is also concave up. What about this? If you take a look at this and this and draw a secant line, this is 0. And if you take a look at this and draw a secant line, it's negative, right? It's 0 to negative. It's decreasing, right? So for this shape, we call it concave down. Oh, what about this? It looks like it's increasing. No, it's not. Although the overall graph is increasing, the slope is actually decreasing. Why? Think of secant line. It's a positive slope. It's 0. It's decreasing from positive to 0. So for these kind of shape, we also call it concave down. So taking everything into consideration by looking at the slope, because for these 2 occasions, as the slope is increasing, we call these 2 concave up. However, for these 2, the slope is decreasing, so we call it concave down. That's what concavity of a graph is. Whether a certain region is concave up or concave down, we call that as concavity of a graph, okay? As I told you, I should have had this slide before. Position, velocity, acceleration. Position is the location of an object. Velocity is the change of that position. So it is basically the slope of position. And acceleration is the slope of velocity. As we were having a lot of real world problems and word problems, these will kind of come up a lot, although it's not a physics class, so I thought it's good to kind of go over this. So what's velocity? Slope of position graph. What's acceleration? Slope of velocity graph. That's all you gotta know. Let's solve some sample examples. If a position versus time graph is given below or on the right side, find the acceleration in the interval 0, 2. Okay. So we're given a position graph, right? Yeah. And then let's think of what is the average rate of change of this function. In other words, let's find the velocity graph first. Okay. The average rate of change if you take a look, let's find from the average rate of change of this point and this point. It's 0, 10 and 2, 6 as it's given, right? So if we do change in y over change in x, it would be 6 minus 10 over 2 minus 0. So it'll be negative 4 over 2 or negative 2, right? So we can know that the velocity graph will have the slope of negative 2. So basically, we can say that this is the velocity graph. Okay. What about acceleration then? Acceleration is the slope of this function. So it would be y equals -2. You understand? So the answer for this question would be -2. You understand? This is kind of hard to kind of visualize to some extent, but if you kind of comprehend what we're doing and then kind of take into consideration what I'm kind of trying to teach like all of you, it would be way better. Okay. So just think of how can I find the change, because this is a quadratic function, right? How can I find the change of the average rate of change of a quadratic function? We're first going to take, because the interval is given, we're going to find the average rate of change by drawing a secant line, which is -2. And the function that can represent the secant line would be y equals -2x, right? Now, what is the slope of that? We know that the m is the slope. So the acceleration would be y equals -2 graph. So the overall answer can be just -2. Let's do the same thing for in a word problem, okay? This is actually driven from the previous question, so let's just bring it up. We found that the average speed is -18, right? So we're going to use that information. So we found that the velocity graph is y equals -18x, right? Then what's the acceleration of that? This is the slope of a linear function. So the answer of this would be -18. And I forgot to tell you, for this, the unit is not given, so you can just see -2. But for these kind of questions, the unit is given. The unit for acceleration is feet per second squared, or meter per second squared, okay? Let's look into this. Position versus time graph is given below. Find the acceleration in the interval of 0,5. Okay, what's the slope of this linear function? 1, right? So the velocity versus time graph would have a shape of this, right? What is the slope of this velocity graph? It's actually 0, right? So if you think, if the original function is a linear function, the change in average rate of change of linear function would be 0. So the answer for this question is 0. What about this? It's also linear function, so we don't have to do anything. The answer is just 0 because the question is asking for acceleration. Let's solve some problems about concavity, and that'll be the end of today's lesson. So we're going to look into what intervals are concave up and what intervals are concave down. Okay. Yeah. I told you that if it has like a shape of this or this, it's concave up. I told you that if it has a shape of this or this, it is concave down, right? And I also explained you why. By drawing a secant line, you can know that this is from negative to positive. So this part is increasing, right? In terms of rate of change. For this thing as well, it's changing from 0. Sorry, this is 0 to positive. So this is also increasing, right? For the concave down parts, this is this positive slope, this is 0 slope. So this is decreasing from positive to 0. For this part, it's 0 and it's negative slope. So this is also decreasing. So I've explained this to you guys. By looking at this graph, we can know that this entire part up until here has this shape. So we can say that what's concave? Upward. Negative infinity, sorry, round bracket, because you can never include negative infinity. 2, 1. What is concave down? The red part, because it's having a shape like this. So 1 to positive infinity. That will be the right answer for concavity question. Same question for this. This is having a shape of concave up. So the answer for concave up will be negative 2, 2, 2. What about for concave down? These two are both having shapes of concave downward. So the answer for concave down would be negative infinity to negative 2. And 2 to positive infinity. Yeah, that would be the right answer. Hope you understand all the concepts that I explained here. If you have any questions, just feel free to email me. Thank you and have a